Okay, we continue again to part 3, Introduction to Deep Learning. So what is actually deep learning? The deep learning is when you hear the term deep learning, just think of a large, deep neural network. So this is based on the speech by Jeff Dean, Google senior fellow. He said that deep learning is just large, deep neural network. So we have very deep layers, for the neural network. Okay, when we see the amount of data versus the performance, the old machine learning algorithm cannot do any better if we add more data. So they just stagnant in here, static, They don't have any improvement. But with the deep learning, they can improve better with the big amount of data. The more data that you give to the deep learning, the better the performance is. So why do we need to go deep? To approximate complex decision boundary. And deep learning can do the learning hierarchical using representation learning, and it also works well in practice for the visions and audio and text. Okay, so from the decision boundary perspective, we can see something like this. We start to learn how to separate between this instance and with this instance, with this class and this class, using initial random weight, And then we present a training instance, and then we start adjusting the weight. And then keep adjusting a tiny adjustment until eventually we can draw something like this, perfect boundary. Okay, so what's the point? Weight learning algorithm for neural network is not good enough. Why? Because they work by making thousand and thousand tiny adjustments, each making the network do better at the most recent patterns, but perhaps a little worse on many others. But eventually, this tends to be a good enough to learn effective classifier for many real applications. Okay, so this is, you cannot solve something like this using the linear functions. You need something else, which is nonlinear functions, to draw the perfect decision boundary. Okay, I'm going to explain how the deep learning works to solve the digit recognition problem. Okay, so from the image, we need to break it down into small pixels like this, and then each single pixel in here become our input, and it will be present in the input layer. Okay. We pass the input layer to the hidden layer, the first hidden layer. So what is actually this unit doing? Actually, this unit can become a self-organized features detectors. What is feature detectors? They can detect the important features from the digits, from the image. Okay, for example, it will send strong signal for a horizontal line in the top row, ignoring everywhere else. Okay, so the first input, the couple first input represent the first line. This unit can detect whether there is a horizontal line or not in the first line. And then, how about this one? Okay. So this represents the dark area in the top left corner. So the top left corner, this unit can also detect whether there is a dark area or not. Okay, if they can see something like this, they can send a strong positive signal. Okay. Oh, I know that there is some dark area, so I send a strong positive signal. So actually, this unit can detect the features. What features make you expect a good neural network to learn from something like this? So the feature can be vertical lines, for digit 1, 4, and 9, for example, and then horizontal line for 0, 2, and 7, or small circle, like in the digit 2, 6, and 9. How about the positions? The position can be in the bottom, in the middle, or in the top. Can they doing that? Okay, yes, the answer is yes, because they have more than one layers. Successive layers can learn higher level features. So for example, in the first layer, you can only do this for detecting the first line, the horizontal in the first line. But the next layers, you can have something like this. Okay, I can detect the second row. Is there any horizontal line or not? And then more than that, they can learn about the another features on different positions. Yeah, they can detect the vertical layers as well, horizontal layer, vertical layers, and the small circle. Okay, so this is the first layer, the hidden layer, for example. This is the second layer, the third layer, and then finally come up with the output. Yeah, the output is the your guess, the predicted class. Yeah, the predicted class. Okay, so by that explanation, multiple layer makes sense to solve the problem. So this is also how our brain works. So we have several layers in our brain. Yeah, we keep passing the signal, passing the signal, passing the signal until the very outer part. Many layer neural network architecture should be capable of learning the true underlying features and features logics and therefore generalize well. But until very recently, our weight learning algorithm simply did not work on multi-layer architecture. Remember when I explained about how we draw the position boundary like this? Yeah, actually in real life, adjusting the weight, adjusting the weight by tiny adjustment did not work on multi-layer architecture like this. That's why people invent what we call deep learning, the new way to train multi-layer neural networks. Okay, so how do they train this multi-layer? What is the new way to train the multi-layers? Train this layer one step at a time. Train this layer first. And then you train these layers. And then the next layer, eventually this layer to the output. Each of the non-output layers is trained to be an autoencoder. Here is autoencoder. Basically, it is forced to learn good features that describe what comes from the previous layers. The autoencoder is trained with an absolutely standard weight adjustment algorithm to reproduce the input. Okay, by making this happen with many fewer units than the input, this forces the hidden layers unit to become good feature detectors. So the middle part, the intermediate layers, are each trained to be an autoencoders or similar than that. Actually can detect the features, important features. And then final layers trained to predict the class based on the output from the previous layer. So this is acting as the input, for this output layer. And that's a basic idea. There are many types of deep learning, different kinds of autoencoder, variation of architecture, and training algorithms. And it's very fast growing area nowadays. So this is your discussion topics. Do you think deep learning is supervised, unsupervised, or something else? You can give examples. Explain in a simple way about backpropagations and gradient descents. Explain the advantages and disadvantages of deep learning, and then why deep learning is so popular nowadays, and since when.